Hello and welcome back to this amazing channel. This is Abhinav. Today in this particular video, we will discuss about the Codeforces Round 930, and we will discuss about the problem number A, B and C of this particular contest. So we have three problems, I have solved these three problems. Actually, it took 1 hour to solve the third problem, right? It was a really interesting and interactive problem, right? Let's discuss all the problems one by one. The very first problem is shuffle party. So the problem says that you are having an array, right? And what you can do with that array is that you can basically do some operation called swap k. So what does this swap k operation does? It takes a number k, then it finds the d, which is the largest divisor of k, less than k, not equal to k, and then swaps ad and ak, and you have to do this swap operation from 2 to n number of times, right? So let me tell you, and then basically finally you have to find the position of 1 in the resulting array. So after performing this operation, the array will be rearranged, right? So you have to tell the position of 1 in that array. Let me give you an example. So initially, as we know that arrays are like this. Initially arrays like this. Let's say n is equal to 7, so array will be like this: 1 2 3 4 5 6. Right. Now, what is swap k? So swap k means you will first find the largest divisor of k, which is d, and k. Then you have to swap the indexes at these numbers, right? So currently indexes are same. It is one base indexing. Now you have to do this swap operation for all the numbers from 2, 3, 4, 5, 6, and so on up to k. First of all, you will do it for k. So when k is 2, what is d? Means what is the largest divisor of 2? The largest divisor of 2 is 2, but we cannot take equal to k. So we have to find the largest divisor of k, which is not equal to k. So for 2, it is 1 only. So basically, we will have a swap between index number 2 and index number 1. Okay. We'll have a swap between index number 2 and index number 1. This will become 2, this will become 1. Now when k will be 3, again d is 1. For 3 also, its largest divisor is 1 only. So again swap between this will happen. This will become 3, this will become 2. But you can see 1 is still at 2. So we have to just focus on 1. 1 is still at 2. Okay. Now for 4. So when k is 4, d will be 2. Largest divisor of 4 is 2. So swap between 2 and 4 will happen. Now here 4 will come here, 1 will come here. Now 5. So when k will be 5, d will again be 1. So again 1 and 5 it will happen. Swap will happen. Right. Now when k is 6, so let me, yeah, let's light here. When k is 6, d will be 3. So swap between 3 and 6 will happen. Now when k is 7, d will be 1. Swap between these two. And finally, we will see 1 is present at index number 4. If you will even increase the number, let's say that value of n is 9. Let's assume. So when value of n is 9, what will happen? What will happen? Two more numbers will be added. Now for k is equal to 8, its d will be 4. So now swap will happen between this and this. Now for k is equal to 9, d will be 3. Swap will happen between this. Right. So now if you will see, where is 1? 1 is present at index number 8. Index number 8. So here it should be 1 actually. Here it should be 1. So 8 से 1 होगा. I did one mistake. Here 1 to it. Here it's 8 to 1. So 1 कहाँ पे? 8 में. So if you will see, initially 1 was at first index. Then it went to 2. Then it went to 4. Then it went to 8. And next, if numbers are, you are right, it will went to 16. Because for 16, 8 will be the uh, largest divisor, less than 6. So basically 1 is present in the power of 2. So whichever is the closest power of 2 with n will be the answer. That is what I am doing. Right. What I'm doing in the code also, if you will see, what I did here is, what I did is, he, I am first taking a value n. I'm first taking a value n. I'm taking the value. Initially, my answer is 1 because initially 1 is present at index number 1. But the value of the 1 will swap and will go to all the indexes which are power of 2 and which are less than equal to n. So I'm checking if answer into 2 is less than equal to n, means 1 will go there in some swap. So I'm multiplying. So until I'm getting a value which is power of 2 also and which is just less than n, less than equal to n, I'm taking it and then I'm printing the. That is how we are solving this first problem. I can say that all like this overall this contest was a little bit tricky. That is why its first problem was also tricky, right? So yeah, this is how I'm solving it. I hope that you have got it. If you have any doubt, you can ask that to me in the comment section. Okay, and you can also join Telegram where we discuss these all the post contest discuss. Cool, amazing. Now moving forward, we have binary path. So for binary path, what we have is that you are given a 2 into n grid filled with zeros and ones. Now you have to find the number of interactions at the ith row and jth column, right? Uh, Now, so basically, let me tell you what this problems is saying. And let's take these example only. This problem is saying that there is a path with size 2 into n. So for example, this is the matrix that they are giving. There are two rows and n column like this. So for example, this is row 1, this is 1. Okay, this is given to you. So here it is 0, 0, 1, 0. Then it's 1, 1. So you have to find two things in this particular path. So what they're asking is that there is a person or grasshopper basically who is currently at index 1 comma 1. So for them 1 comma 1 is this. They are assuming one base indexing. So the grasshopper is present here. Okay, is present here. Now he has to reach this point, this last point. Now they're asking how many different ways are there to reach here and not simple paths. You have to first find the shortest path, or basically not the shortest path, it's actually lexicographically smallest path. Lexicography means you have to first find the string of the path from here to here and which is lexicography small. For example, if I'm saying path is 0010 and I'm saying 0110, so this is smaller because there are zeros present. So I hope that you guys know what is lexicographically smaller, right? So if you will find, basically what we will try is, we will try that as much zeros we can have in our path, because more zeros in our path, more it will be lexicographically smaller. So if we will start from here, okay, we will start from here, we will go here because there's a zero. Now after this zero, we can go either down, either move forward, but we will only move forward where there is a zero. Okay, so for example, initially there was 1, there was 0. So obviously the choice was move towards 0. Obviously choice is move towards 0. But, and one more thing, that they can only move either right or either down. They cannot go up or left. Right. So if once you gone down, you cannot go up. Right. You have to go down only once. That you have to choose. Okay. Because the path will be that only. Path will be either like this, either like this, either like this. Basically, you have to go down once. So number of times you can go down and then continue your journey is a number of ways. Right. That is what they are basically asking you. Right. So what we will do here is, for example, in this case, when zero is here, zero can move down also, but grasshopper will not move because down is one. Now here he has option. He can either go forward, either go down. Let's say he will always try to move forward, because if he goes down once, he cannot go up. He move forwards. Now again there are two things. Either move forward, either go down. But because move forward is zero, he will always move forward. Now again, forward is also 0, down is also 0. Where to go? Right? Where to go? So it will again move forward. Okay. Now again, what will happen? Either move down, either move forward. So both has ones. So when both has ones, it can either go down, it can either move forward. But the thing is, see, the thing is, when there is at the forward it has 1 and down it has 0, that means he has to definitely go down at that point. For example, if we will come here, now if we will move forward, there is a 1. So from here he has to definitely go down. He cannot move forward. Are you getting? From here he has to definitely go down. He cannot move forward. Right? I will again tell you. See, what I am saying is, for example, he initially starts from here. Here he has to move forward because there is 0 in the forward. Then he has both the choices. But let's say he choose for forward only. Then again here there is only one choice, forward, because there is a 0. Here again both the choices, but he choose for forward. I will tell you why. Then again both choices he choose for forward. Both choices he choose for forward. Now there is no choice grasshopper has. He has to definitely go down because there's a 0 in the down. He has to definitely choose 0 only. He cannot go forward with 1 because we have to get as much 0 as we can. Right? तो यहां से उसे नीचे आना ही पड़ेगा. अब यहां से आना पड़ेगा तो एक हो गया. This is always a path. It will go like this. Now, if we know that at this point, grasshopper has to move down. तो हाउ मेनी अदर वेज वर देयर कि यहाँ की बजाय वो यहाँ से डाउन हो जाता, यहाँ से डाउन हो जाता. ऐसे कितने वे बन रहे हैं? दैट इज व्हाट वी हैव टू सी कि बिफोर दिस डाउन हाउ मेनी डिफरेंट वेज वर देयर. सो देखो आंसर तो ये होगा, दिस विल बी योर शॉर्टेस्ट पाथ व्हिच इज 0 0 1 0 0 1 1 0 1. This will be your shortest path, your answer. But to find number of ways, what we will do is we will find how many such indexes were there where this grasshopper was having multiple options, and which was also just before this down. So you can see just before this down, this was first location where he was having option. He can go forward also, he can go down also. तो बेसिकली वो यहाँ से भी डाउन कर सकता था. दोनों उसको सेम 1 1 ही पड़ता. एक ऑप्शन तो ये हो गया उसका. एक ऑप्शन उसको ये भी होता क्योंकि यहाँ से भी इफ ही इज गोइंग फॉरवर्ड इट्स 1, if he is going downward again it's 1. This was another option. This was also an option. If he will go forward, he can get a 0. If he go down, he can get a 0. So basically you have to find that at this point where he is going down, how many such uh, you know how many such options are there just before it in consecutive manner where he can choose any one of that. So because there are four options कि वो यहाँ से भी नीचे आ सकता था, वो यहाँ से भी नीचे आ सकता था, यहाँ से नीचे आ सकता था. That is why for this test case, if you will see, the output was 4 and this was the shortest path. Now if you will see the other test case, this one, 1 1 0 1 1 1 0 1 1 1 0 0. तो इस केस में क्या है, इन दिस केस व्हाट इज हैपनिंग इज he has to definitely go down from here, definitely, because यहाँ देखो why I'm saying this, let me first draw lines. Okay, see, for example, if he is starting from here, so here he has two options, either go forward, either go down. He can take both the options, but he will take first upper one only. Up here he has only one option choice, move forward. Here also he has only one option choice, move downward. Here one option choice, move forward. यहाँ पे सिर्फ एक ही चॉइस है. He has only one path to move downwards. He don't have any other option to move forward. एक ही जगह है यहाँ पर जहाँ पे उसको मूव डाउन करना ही पड़ेगा, बिकॉज अगर आगे जाएगा प्लस 1 है. और इसके जस्ट पहले आई एम सेइंग जस्ट बिफोर इट देयर इज नो सच ऑप्शन वेयर ही कैन गो डाउन। वो यहां से भी कर सकता था पर नहीं करेगा, क्यों? तो यहाँ पे 0 है, यहाँ पे ही हैज 2 ऑप्शंस, और उसके बाद एक ये भी तो आ गया। सो यू वांट जस्ट बिफोर कितने ऑप्शन है, वेयर ही हैज 2 ऑप्शंस, मूव फॉरवर्ड आल्सो, मूव डाउन आल्सो, राइट? So what I'm doing here is, in the code, if you will see, what I'm doing is uh, a very complex code. So here first I'm taking the input. Okay, I'm converting this given string into a array of strings. Now initially I'm taking my answer as ARR 0 comma 0 because it is present at 0 comma 0 initially here, right? Initially I is 0, j is 0, basically it's index, so he's present as 0 comma 0. X is 1 basically because initially there will be only one ways. Okay, and ways is also I've made 1. Now see, if ARR I comma x plus 1 means if forward is 1 and downward is 0. अगर forward 1 है, for example if he is here, if forward is 1, downward is 0, so definitely he has to go downward, definitely he has to go downward, right? So I am doing I plus plus means I am going downward, and I am adding that also in the answer, which is the answer string, shortest path. And because we are calculating कि उस 1 के पहले, before that down, how many consecutive x were there, that we were storing in this x, that I am making it equal to waste. कि भाई जब हम यहाँ down गए थे यहाँ पर, उसके पहले 3-4 ऐसे x आए थे जहां पर आप दोनों में से कोई भी ऑप्शन ले सकते थे, तो उतने 4 वेज बन सकते थे, 4 वेज वर पॉसिबल, राइट? दैट इज व्हाट वी वर डूइंग नाउ, एंड दिस वाज द थिंग कि जब आप फॉरवर्ड जाओ और नीचे जाओ दोनों सेम बन रहे हैं, व्हाट आई सेड ना कि हाउ मेनी सच पॉसिबिलिटीज आर देयर, इफ यू विल मूव फॉरवर्ड, यू विल मूविंग डाउन, बोथ हैव सेम ऑप्शन. If there is such a possibility, increase this value x, means there is a option, इस वैल्यू x की वैल्यू इंक्रीज कर लो, एंड जब भी वो नीचे जाए तो उसके पहले कितनी कॉन्सिक्यूटिव ऐसी वैल्यू हो चुकी हैं वो आपकी वेज हो जाएंगे, वेज इज इक्वल टू. बट अगर एल्स केस आ रहा है, मीन्स इफ उसको आगे ही जाना पड़ रहा है, मीन्स मूविंग डाउन इज नॉट पॉसिबल, ही हैज टू मूव फॉरवर्ड ओनली, then at that time you have to again make x is equal. For example, in this case, after this, so here maybe it was both the options are present, we can do x plus plus, but here again he has to always move forward, he cannot go down. ये वाला भी क्रॉस हो गया, यहाँ भी वो डाउन नहीं कर सकता, ठीक है? तो अगेन x is equal to 1 पे, and this all conditions are where if I is at 0, means if I at the top, if I is already at the bottom, if that I is already moved down, अगर वो already down है, then nothing to check, simply move forward, simply j plus plus. And if let's say he has just moved completely to the last column, let's for example if he is going in the first row itself and he reached the end last column, then definitely he will go down. That is what we are doing. Again v is equal to, then I'm printing the answer in the way. So this was actually a complex problem, I can understand, and it took for me also some extra efforts to explain this. But if still if you have any doubt to understand this problem, you can comment down your doubt, okay? Or you can also join Telegram channel, right? But yeah, that is what we were doing. मैं फिर से एक्सप्लेन कर देता हूँ कि देखो, अगर एक इन हिंदी लेट से वो जो हनी बी है उसको कहीं ना कहीं एक इंडेक्स से नीचे आना पड़ेगा, ठीक है? लेट्स से अगर ये है हमारे पास में, ठीक है, तो बीच में कहीं ना कहीं एक इंडेक्स से उसको नीचे आना पड़ेगा. अब और कहीं पे एक जगह उसको मजबूरी होगी कि नीचे आना ही आना है. ऐसी दो जगह होंगी, या तो 1-0 आ जाए कहीं पे, मान लो मान लो कि यहाँ पे 1-0 आ गया. जब 1-0 आ रहा है तो उसको नीचे आना ही आना पड़ेगा, बिकॉज नीचे 0 है, उसको यहाँ से नीचे आना ही पड़ेगा. और अगर वो यहाँ से नीचे आ रही है तो बात है कि इसके पहले भी वो कहीं से नीचे आ सकती है ना. तो ऐसे कितने पॉइंट्स होंगे जहां से वो नीचे आ सकती है इसके पहले से ही, जस्ट बिफोर कितने पॉइंट? तो क्या ये एक पॉइंट है? हाँ, एक पॉइंट यहाँ बन रहा है कि वो यहीं से नीचे आ सकती है, क्योंकि इसके आगे जाके तब भी 1 मिल रहा है. भाई वो ऐसे जाए तब भी 0-1-0 मिल रहा है, ऐसे जाए तब भी 0 1 0 मिल रहा है। सेम वो यहाँ से भी नीचे जा सकती है, क्यों? क्योंकि यहाँ भी दोनों सेम है। मतलब ऐसे जाएगी तब भी 0 0 1 0 मिल रहा है, ऐसे जाएगी अ, ऐसे तब भी 0 0 1 0 मिल रहा है। तो यही निकालना है कि और अगर ऐसे जाएगी तब भी 0 0 1 0 मिल रहा है। तो मतलब 3 ऑप्शन हो गए। एक बार ऐसे जा सकती है, राइट? एक बार ऐसे आ सकती है और एक बार ऐसे आ सकती है। 3 ऑप्शंस हो गए ना, क्योंकि 3 कॉन्सेक्यूटिव में मिल गए। That is what I am doing and calculating using this, right? So it's a little bit complex, but I hope that you got it. If you have any doubt, again, please ask me in the comment section. Amazing. Let's move forward to the last and final contest for this, final video, final problem for this particular video, which is this. This is was an interactive problem. So basically, interactive problem वो होती है guys that you will ask for some query and the other person will respond to that query, right? That is basically interactive problem is. So here basically what they are saying is there's a secret permutation given to you. The permutation contains values from 0 to n minus 1. Let's say if n is 7, so values will be 0, 1, 2, 3, 4, 5, 6. And also these values are present in some random manner. For example, like this. Right. So let's say this is the permutation present. For example. But this is not known to you. You are just given with the value of okay here one value. So you are just given with the value of this n. And you know that in the permutation, values from 0 to n minus 1 are present. Now what you have to find is, you have to find the indexes of two numbers which has the maximum XOR. For example, here, the maximum XOR values will be 6 and 1. When you will do the XOR of 6 and 1, it will give you cool. So, that's the basic thing. Now what you can do, what type of query you can ask. So in each query they are asking you, if you will see here, in each query what you can do, you can give question mark, then you can give 4 indexes. You have to give 4 indexes in each query. Indexes are a, b, c, and what they will return you, they will first find the value of a or b, then c or d, basically not the indexes, the particular elements in the array. Basically, let's say if array is ARR, so A B A C A C or PA मान लो. मतलब basically for that index, the value present in the permutation, they will find the OR value of that, and they will give you the comparison out of it. If it is greater, equal to, or less than, that is what they will give you in the output. For example, in this case, if let's say if you give the uh, query as 2136, so they will first do OR of, I'm saying OR here, OR of 0, 2 index, then 1, and then OR of 3 and 6. 3 index is 6. This OR will be 1, this OR will be 6, so greater is this. So output will be greater than sign because this is greater. Means OR of index number 3 value, index number 6 is greater. So this is what they will give. And by doing this, basically you have to output two values, two indexes which are basically having maximum XOR. In this case, those indexes will be 1 comma 3. If you will do XOR of 1 and 6, it will, which is maximum. So first of all, guys, let me tell you how you will get which indexes are having or which numbers will give you maximum XOR. So guys, if you will see, let me take a different value. Let's say that your n is 11. When n is 11, there will be multiple. Let's take a random permutation. So 1 2 0 1 2 3 5 6 7 8 9 10. Okay, let's take it as 10 only. So because n was 10, you can see here that we have taken numbers from 1 to 9, 0 to 9, from 0 to 9. For these numbers, if you will see, which will give you the maximum value of XOR. So if you will see, first let's take the maximum number of this 0 to n, 0 to n minus 1. So obviously n minus 1 will be maximum. So 9 will be maximum, which is 1 0 0 1. So what should be solved with this 9 to get maximum value? it will be 0, 1, 1. This will give you maximum, which is nothing but 6, right? This is nothing but 6. And how I got it? Because for all the bits which are not set in 9, should be set in that number. And obviously this will be present in the array. So 6 or 9 जो है हमारा answer होगा, which are present in index number 1 and 6. But how you will find it? Because this permutation is not given to you. So what I will do is, what I have basically did it, if let me explain the code also side by side with you. I did have one wrong summation also for this, and it took me around 1 hour to solve the whole problem. अरे भाई server not on. हाँ, so what I first did is, I first, if value of n is 2, obviously answer will be 0 and 1. First I calculated the maximum number of the whole, like basically I found that at what index the maximum number of the whole permutation is present, which is basically this 9. So first I figure out that कि किस index पे इस पूरे array का maximum number present है, which is 6 here, and I stored it in a variable called z. How I did it? So I created a function here for query, where I will give ABCD and it will print the query for me, right? So what we are doing here is, it will also, by the way, do this also for us, but I didn't. I did it manually later. Yeah. So what I'm doing is, I'm starting from index number 0, and starting from index number 0 for all the indexes from 1 to n minus 1, from 0 to n minus 1, I'm making query. First 0 comma 0, I comma I. Then whatever z comma z, I comma I is. And if let's say I is greater than z, see, z is or z, sorry, this will give you or, right? So z or z will be z only, I or I will be I only. Let's say I am giving the query as z comma I, right? So it will be element at z or element at z, element at I or element at, it will be element at z, element at I. So basically this will compare between the elements only. This will not, the or will not affect their value, right? Let's say मैं बोल रहा हूँ कि initially I took my z as 0 and I am starting my I at 1. तो initially वो 7 or 7 and 6 or 6 करे, basically 7 and 6, and because 7 is greater, it will output this. Because we want the greater value, we are finding for the maximum value, or basically the index where the maximum value is present, we are finding for that. So if z is greater, means we are having the correct index, but if I is greater, means the sign is opposite, this one, that I is greater. If it is giving this sign, that means at index number I maximum element is present, so I'm storing j is equal to I. This is simple how we iterate in an array and then find the maximum number. So now in this Z, we have the index where the maximum number is present. Right, great. Now next what I am doing, this is a very, complex logic. I am now here calculating the value of mx. Now what is this mx? Mx is the value which will give you the maximum XOR, which is 6 here. Right. How I am doing it? See, there will be multiple values which will give you maximum OR. For example, we got z. Z means we got the index where our maximum number is present, which is 6. Now we know that if we do XOR of 1001 with 0110, we are getting 1111. But if we do the same thing, let's say with this, let's say with 0111, again it will give you 111. Because we were considering XOR, but they will give you OR, right? They are doing OR. Okay. So if we will, let's say, even do it with, like, there are multiple things now. For example, if there's a, for example, the maximum number that we are having is like this. What we want is this. We want a number something like this, so that it can give you a maximum. Can give you a maximum. But the query will give you maximum or, basically or. तो इतना और तो आपको और भी नंबर से मिल सकता है. आपको ये और इस नंबर से भी मिल जाएगा. अगर आप इससे करो, ये भी आपको ये और दे देगा, सेम और देगा. पर आंसर तो ये होगा ना. तो सबसे पहले you will find all those numbers which are giving you maximum OR value, because a number is giving you maximum OR, it will definitely give you maximum XOR. How? Let me tell you. First of all, I got z. Z is the maximum number. I am taking current index mx and taking current I. I'm finding it. Now, if the symbol is greater, means the OR of z and I is greater than the OR of z and max. Means this I can be our that number, which is 6. Means this I will definitely give greater XOR value than mx. So we made mx is equal to I. कि भाई ये I जो है ये आपको greater XOR value देगा. But we want maximum XOR value. For example, ये भी आपको 111 दे रहा है, ये भी आपको 111 दे रहा है. But we want कि और तो maximum ठीक है, we want XOR maximum. So if we want XOR maximum, which will be better? So here we just want ones where zeros are present. इसमें वहां तो वन है ही जहां पे जीरो प्रेजेंट है. It is having extra ones. We don't need extra ones because if there are extra ones, one and one will become zero in the XOR. So we don't need extra one. So basically we win the minimum of all such values which are giving this one. So if there will be multiple values जो 111 देंगे, ये भी आपको 111 देगा. This will also give you 111. Right? Am I right? These all will give you 111 if you will do OR. If you will do OR of them. But we want such value where only zeros at the bit where in the original max there is zero, we want one there like this. बस जीरो की जगह वन चाहिए, बाकी जगह वन की जगह जीरो चाहिए. So if you will get the minimum of all such values which are giving you maximum, that will be your second value, just like here it's 6. तो बहुत सारे ऐसे नंबर हैं जो आपको लास्ट में 111 देंगे. So here we are searching, okay, if this number index number I is giving maximum OR value, just store it in MX. But if there is a number I which is giving same OR value just like MX is giving, means equal to, for example, this also and this also. This is 7, this is 6. Both are giving same value. But our answer will not be this. Because जब आप इसका XOR करोगे 7 के साथ, XOR will be less. XOR will be maximum only with this value, which is minimum. So minimum of all such will be your answer. So when both mx and I are having same OR value, we will get minimum of those. How? We will get mx and I. So if mx is smaller, it's fine. But if I is smaller, I अगर smaller आ रहा है, mx equal to I कर. This is how we are printing the maximum value of the whole array at what index it is present, which was z6. And then by doing this, we are also finding the index of this 6. So we are printing 1 comma. Right. This is how I am doing, guys. This was an interactive problem, a really interesting problem. Complex also. I hope that you have got the complete understanding of it. Still, if you guys have any doubt, please feel free to ask me through the comment section or through Telegram. Okay. If this video is helpful for you, please comment helpful and please subscribe to this amazing channel. Thanks a lot.